Good evening, all of you. Am I audible? Yes. Am I audible? Yes, participant, please reply so that we can start. Okay. Okay. Thank you, Manish. Thank you. So, welcome to the day 9 of our online FTP, Smart Healthcare Technology Opportunity and Challenges. Okay. So, today we have a total 4-hour session where 2 hour is being split. Okay. So, in first lecture, we will be discussing about the case study of the variable technology. Okay, and variable technology will play a very crucial role in our healthcare domain. Okay, we already discussed at our last lecture when we mentioned that what is the role of the variable technology in healthcare technology. Okay, so let us discuss on that. So first we will see brief overview of the smart variable technology. Then I will discuss about the 4 case study where I am personally working on. Okay, and then we will talk about the variable technology that could be useful for the diabetes as well as some sort of pandemic like COVID-19. And finally, we will summarize with the variable technology. So this is just a acknowledgement to because whatever the work that is being discussed today, it is in the collaboration of these all people. So first one is the professor from University of North Texas, USA. Okay, and other 4 are my PhD students who actually received their degree. Okay, now what is smart variable device? Okay, because variable device is playing a very crucial role in a healthcare domain. It allows us to capture the data through our daily activity. Okay, so it is something like that. I am doing my routine activity, and still I could be able to capture the important parameter. Okay, so smart variable device. When I say that it is electronic device which can be worn on your body. Okay, so that can help us to collect important health parameter that we can transmit to store at the cloud and which we can analyze and take some sort of decision out of it. So ultimately, whatever the data which is being collected, that data is being processed through some AI ML algorithm, and we're trying to derive some information out of it. Okay. So smart variable devices which are available in a healthcare domain is a smart watches. Okay, where possibly smart watches and fitness band will allow you to capture the important you can consider the parameter like heartbeat, your pulse rate, okay, your blood pressure, okay. So all this you can monitor along with your daily activity, and the data is being stored at the cloud. So even though if I'm not able to track them during my daily activity, then at the end of the day, whatever the data which is being stored, that actually can help me to analyze. Okay. Now, apart from that it can also help us to get some sort of personalized treatment. Okay, because this data is being collected from a particular person. Now, through this, we can train the model, and whatever the model which is being trained, that definitely help us to get the prediction accurate for that particular person. Okay, so personalized healthcare management would be very well managed with the such kind of smart variable device. And smart watches and fitness trackers are the you can consider the capturing the most of the market in the smart variable technology. Okay, smart clothing is also being evolved where means it can actually help us to get some sort of your ECG images. Even they can help us to actually get some sort of vital parameter like a heart rate. Okay, so that actually will be helpful. Okay, and it will looks like a normal clothing only. Okay, so it is something like that along with my daily activity. I can capture the parameters. Okay, then augmented reality glasses Okay, so that also help us to get the some sort of healthcare management. Okay, now when I look at the evolution of the healthcare devices, okay, so such kind of smart variable device which actually started in first 1975, where pulse calculator watch is there, which actually help us to get the pulse value of a particular person. Okay, that is been evolved in 1975. Then 1987, we used to have some sort of hearing aid. Okay, so which actually help us to amplify the voice. Okay, so that is for the basically old age people. At certain age, you are not able to hear the sound clearly. Okay, or somebody is speaking in front of you, then you are not able to actually correctly means identify those speech signal. So for that, the hearing aid could be work as an amplifier which actually boost your means voice and it and so that the old age people can hear it clearly. Then the Microsoft Watch smart watches. Okay, so these are also the first of such kind of smart watches where the important parameter like heart rate or pulse is being measured by watches. Okay, then some sort of fancy kind of design is coming right now. The Fitbit is also developed as such kind of variable device. Then your similar kind of device is job on up. Then there is a Google eyeglass that is also very means very popular. Okay, where means it can means help us to actually it means visualize some sort of important information. Okay, then Apple smartwatch, which is currently very popular. Okay, that is also being useful. Apart from that, you have some sort of AR device. You can have some sort of device for a visual aid people. So currently means there are some revolutionary, you can consider the research has been observed where it's through a glass. Even blind people can also visualize the footprint of the whatever the image is which is in front of his eyes. Okay, so smart variable technology has actually evolved in pretty much in an advanced stage from last 50 years. Okay, so for a healthcare variable devices which are available, okay, which actually help us to get your ECG signal to basically observe the heart activity. Your glucose monitor is basically helpful to measure your body blood glucose. Fitness and lifestyle. So that means the smart watches and fitness tracker. So those are very popular because such kind of fancy band or watches we used to wear it. Okay, because that could be your integral part of your body. Okay, where you used to wear the such kind of device. But now, along with this device, they can help us to get some important health parameter. Okay, so that's why they are popular, and the cost wise also means they are not actually charging much. Okay, so within possibly 500,000 rupees, you will get the very good means smart watches or fitness tracker, which actually help us to get the important parameter. Apart from that, there is some sort of industrial military application where you have some sort of safety measurement and augmented reality helmets are there. Fashion and entertainment, that smart clothing and your fashionable glasses are there, which actually help us to get the important health information. Now, when we talk about a smart variable technology, then definitely the role of the sensor is very important. Okay, we talk about the IoT. Okay, so when I consider Internet of Things, then things is ultimately my sensor. Okay, sensor will capture the important parameter. Okay, we have already seen the one lecture of a biosensor where the biosensor can be also plays a very important role. So any kind of sensor which actually help us to get the some important parameter, the information like a ECG, EPG, EMG, your accelerometer, your gyroscope. So all are important. Okay. So you can have a connectivity since we are talking about the IoT technology. So sensor will collect the data. Okay. But definitely you want to offload into some sort of cloud system in order to store them and to have some sort of long-term monitoring. Okay. So for that you can have a Bluetooth, Wi-Fi, FG or 5G or IoT technology. Okay. Apart from that, AI and data analytics are very important. Okay. So whatever the data which is being stored at the cloud, okay. So those data has to be processed. Okay. So from the data, we need to derive the information. So if you remember our first class where we talk about the data mining, okay. So from the data, we need to discover the knowledge. Okay. And that knowledge is basically pertaining to some application. And in a healthcare domain, we want to take some sort of decision. Okay. Maybe I want to go for some sort of monitoring purpose, or maybe I want to go for some sort of treatment purpose. So for that, the AI and data analytics algorithm can be very useful, and they can actually help us to get the personalized solution, which may vary for patient to patient. Okay. And there is some sort of mobile app integration. Okay. So whatever the data which is being processed, okay, that could be easily available at the end user through a mobile phone. Okay. So data I can visualize or data I can interpret at any point of time, and I can easily share those data through a mobile phone with the various applications to a doctor or a caretaker. Okay. So application of such kind of smart variable technologies, it can help us to remote patient monitoring. Okay. So I can monitor the patient at remote. Okay. So this is very important for a country like us where we have a very huge population. Okay. In a rural area where there is a scarcity of the hospital as well as the supporting staff for that. Okay. So for that, the doctor or a healthcare provider can easily monitor the patient which is sitting at the remote location, and through which they can provide some sort of telemedicine. Okay. So chronic disease management, definitely the smart variable technology is playing a crucial role. Because chronic disease, we have discussed that they are gradually built up inside the body and they don't have some sort of visible symptom. Okay. Since there is no visible symptom, I will not be able to identify the root cause of them. Okay. And sometimes I could be able to figure out them at the later stage, but at that time complication has already been started, and the reversible possible is also very much difficult. Okay, if a illness is being identified at the later stage. Okay, so definitely the variable technology will allow to track my health condition in my daily routine activity. Okay, so that the whatever the later complication, if it has to be arise from some sort of critical condition, that could be avoided. Okay. The fitness, definitely how many steps. So that is very popular because the smartwatch is also providing that you can set a goal that this much steps I want to walk in a day. Okay. Even our honorable Prime Minister has addressed that that we need to at least go for a 10,000 steps in a day. Okay. So that goal you can achieve with the easily with the some sort of smart watches and fitness tracker. Your calorie count also you can identify. Okay. So according to the how much you walk and whatever the activity that you have performed, according to that whatever the calorie burn from your body is required. So that is also could be possible. Your heart rate you can easily measure. Okay. Because heart rate is very important to actually identify the health condition of your heart. Sleep tracking. Okay. So if a person is having some sort of sleep apnea problem or maybe some sort of having some sort of different mental problem, so because of that, the sleep, because sleep could be considered very important vital part of our body. Okay, so that ideally we should have a 6 to 8 hours sleep. Okay, if you don't have a adequate sleep, then it could lead to some sort of problem regarding to the heart. Okay, so usually that is being observed that heart attack patient or whatever the you can consider the heart or CVD instance that is being built up because of not the proper sleeping habit of our people. Okay, safety. So safety related variable device also that can actually help the fault detection for the elder people. Even I can track through a GPS that where they are currently situated, and so that if any kind of point of care mechanism is required to help them old people, then I can actually do that. That basically the safety in the industry could be also maybe managed. Okay, for the sports person also the optimization, basically for the limb we have talked about. We are going to discuss today also the upper limb application. Okay. So for the sport person, their lip activity is very important. Okay. So if they want to monitor their progress of the some sort of rehabilitation also for any kind of injury. So for that, the smart variable technology can help us to track them. Okay. So now we are going to discuss various kind of case study that we can have in our smart healthcare device. Okay. So one of the applications where we are working currently, okay, very extensively is a diabetes management. Okay. So and the control for that also. So diabetes is closely related to your glucose. Okay. So if I figure out the diabetic patient, the diabetic patient has almost double in every decade. Okay. So currently we have around 450 million people which is suffering from a diabetes around the world. Okay. Now if you are a diabetic patient, then you need to measure your body blood glucose regularly throughout the day. Okay. Ideally, if you are a diabetic patient, then you need to measure your body blood glucose at least 3 to 4 times in a day. And if you can monitor or track them for every hour or every half an hour, then it would be very much helpful. Okay. So if I consider a diabetic, then once you enter into the diabetic condition, then diet is also very important. Okay, so that you need to decide that what you should eat and what you should not eat. Okay, so for that also we require some sort of a, you can consider a smart solution. Okay, which can help us to such kind of diabetic case. Okay, currently there is no smart healthcare technology which is available for the smart diabetes management as well as a measurement. Okay, so now as I said that for being a diabetic patient, you need to measure your body blood glucose value frequently, or you should measure it recurrently. Okay. Now, when I consider glucose, see, glucose is very important particle of your body. Okay, because we cannot survive without the glucose. Okay, and whatever the food item that we are consuming, through which we are actually consuming the glucose. Okay, now if your body is not having an adequate glucose, then it is very critical condition. So that's why when when you are being admitted into the hospital, then first thing that you will observe that patient is being put under the observation with having a glucose bottle continuously dipping inside the body. Okay. So that actually suggests that glucose is very important and essential component of our body. But excessive amount of the glucose we should avoid. Okay. And if I look at currently the solution to measure the body blood glucose, then there are two ways I can measure the body blood glucose level. Okay. So first is I can go to a laboratory and I can measure the body blood glucose, which you consider is the one of the very popular and the very traditional approach. Okay. Where I visit a laboratory, I give my blood sample and I can get the body blood glucose. So mostly if I want to measure the body blood glucose value, then I need to measure twice in a day at least. Okay. First, without fasting, so at the early morning, without consuming any particular food item, whatever the glucose is being measured, that is the without fasting blood glucose value. And after having a particular lunch, after 1.5 hours or 2 hours, okay, because whatever the food item that we are consuming, that is basically converted into the glucose and that actually being observed inside your blood cell. It will take some time, okay, and that time is typically 45 minutes to 1.5 hours, okay. So after that, if you measure the body blood glucose value, then you will get the postprandial. That means after having the, means your consuming the food item, what is the changes which is being occurred inside your body. So these 2 times is very vital and possibly everybody is doing that or not. Okay. So that is the way that we are measuring the body blood glucose in a traditional way. Second is you can go with the self-monitoring approach. Okay, in a self-monitoring approach, what we will do that we will purchase a one particular device which is available in the market and which is having a some sort of needle and a some sort of you can consider strip. So you need to pinch inside your finger. Okay, then you need to take out the blood, and that blood you need to put or lay it down on a particular strip, and that strip is basically you need to insert into one particular display device, and you will be able to measure the body blood. Okay, now either you will go to a laboratory or if I measure it through a self-monitoring device. Both the type is invasive in nature. Invasive in nature means I need to pinch a needle inside the body and I need to take out the blood outside the body. Okay, and through that blood I am able to measure the body blood glucose. Okay, and both are invasive, so that's why it would be impractical to use them multiple times in a day and throughout the night. Okay, so as I said that ideally you need to measure the 4 times in a day. 4 times in a day for a 1 day, 2 day, possibly I can do it, but not throughout the lifetime that I need to pinch inside the body and measure the body blood glucose. So it is not actually possible. Okay, so that's why we need to think about some sort of better technology which actually help us to measure the body blood glucose value recurrently, frequently inside the body. And if you just observe that diabetes market is very big. So currently we have around 450 people. Okay, but if you just look at this number, then in next 2 years it will reach up to the 700. So which is very, very huge. Okay, so now for this large community, we need to think about the some sort of smart healthcare solution. And presently, it is not available. Now, why we are actually focusing on the diabetes? Because we have discussed so many diseases. Okay, but diabetes is you will consider the root cause for so many diseases of your body. And diabetes is a condition where your body is having a high blood glucose level. Okay, and that we term as a hyperglycemia. Okay, if your body is having a higher blood glucose value, then that we term as a hyperglycemia. Now, if your body is not having the adequate blood glucose value, then we term as a hypoglycemia. Okay, now usually a glucose value is being measured in mg per dl. Okay, that is the unit that is being observed to measure the glucose value. Okay, so ideally your body should have a glucose value in a range of 80 to 140 or basically 130. Okay, but you can extend it to 140. So 80 to 140 is an ideal range of a blood glucose value of the healthy patient. Now that also depends upon at what point you are measuring. So usually when you are measuring it at early morning before having any particular food, then it should be near about 100 or 110 also it's okay. Okay, but it should not go beyond that value. But if you are measuring it after having a lunch, okay, after consuming a food item, then that value is typically in the range of 120 to 140. Up to 140 it's okay. Okay. Now, if your body is having a blood glucose value higher than 140, or maybe ideally it is greater than 150, then I need to worry about. Okay, then it could be a pre-diabetic, or maybe you entered into a diabetic condition. Now, the thing is, there is a myth, okay, where people used to tell that if I consume a sweet, then my blood glucose value is high. No, it is wrong. Okay, so if you are a diabetic, then you should avoid the sweet item. But it is not necessary that for a non-diabetic patient, by consuming a sweet item, you will be entered into the diabetes. No. Okay, so this is actually a wrong perception. Okay, so ideally, if your value is greater than 150, then you consider as to be a pre-diabetic or diabetic. Okay. And if that condition is considered as a hyperglycemia. Okay. Now, if a body having a blood glucose value 70 or lesser than 70, then you need to more worry about it. Okay. Because that condition is hypoglycemia, where your body is not having enough glucose value. Okay. So that means whatever your body cell that actually require energy, and that energy comes from the glucose. And if the body is not having the adequate glucose, then you will not be able to perform the activity. Even if your value is goes lesser than 50, and that is more dangerous. At that time, person may get into the coma condition. Okay, so that's why the glucose is very important, and that glucose value is keep on changing inside my body. Okay, so it is something like that. When I started this lecture at 4 p.m., the blood glucose value is X, but when I end up this particular session, then the glucose value will be Y. It could be 10, 20, or that many substantial difference you can observe in your glucose rate. And that's why the recurrent measurement of the body blood glucose value is very important. And the high blood glucose value is root cause of so many diseases. Okay, like Alzheimer. Okay, where there is a problem of the memory loss. Okay, similarly, we talk about the Parkinson disease. Parkinson disease where actually you have a muscle stiffness. Okay, that also actually related to the some sort of problem of memory. Okay, and your vision problem, eye damage. Okay, so that retinal problem is basically observed if you are basically entering into the diabetic condition. You could have a hearing impairment problem. You could have some sort of dental and the gum disease. Your CVD, okay, where we are talking about the heart attack. Okay, so heart attack is particularly nothing but an instant. But before reaching to that particular heart attack, whatever the CVD problem that is being arrived, that is also because of high blood glucose value inside your body. Your skin condition, your kidney problem, your bladder and sexual problem is being arrived because of the high blood glucose. Your nerve damage and foot damage is being observed because of this high blood glucose value. Now, okay. So there are few questions to engage yourself. Okay. Now, what is the tentative population of diabetes in India? At 450, whatever we have observed, okay, that is your global population. Now, the question is, what is the tentative population of diabetes in India? Okay. Yes, anyone having a wild guess? What could be the value of diabetic patient in India? Yes? Seeking an answer. So whether I can check. Yes, I can see the chat. Yes. What is the population of diabetes in India? So participants are there. Yes. What is the population of diabetes in India? Anyone? Are we connected? Maybe 10,000. No, Sana. 10,000 is very less. And you are considering 10,000 patients. Okay. Even 10,000 is a very less number which annually being added. Okay. 10,000 तो शायद हो सकता है कि हर एक महीने में ऐड होती होगी in diabetic community. 10,000 is very less. 450 million is overall. So what will be the India contribution? Okay. So just to give you the hint that India is having the second largest community of the diabetes. Okay. So we are the second largest, not the first one. First one is China. Second is India. So now what could be the population of diabetic patient in India? Okay. Okay. Seems that means you are not interested to have some sort of case. Okay. So currently we have around 110 million. So according to the report, 101 million of Indian population is suffering from diabetes, and that is a recorded value. Okay, there are more than 70 to 80 million people for which the diabetes is unrecognized, because diabetes is a chronic illness. In a chronic illness, you don't have any kind of symptom. Okay, so ऐसा नहीं कि you have a fever, you have some sort of sneezing, you have a headache. So there is no any kind of visible symptoms you will observe. Okay, so there are 70, 80 million people which are not being recognized. So they are not being included over here. Okay, so there could be a more than 150 million people suffering from diabetes. Okay, now diabetes could be observed with some sort of early symptom. Okay, like there could be a frequent urine excursion in a short duration. You could have a constantly greenness that is being observed. Okay, thirstiness. You could have encountered the kidney problem. Your weight loss, tiredness, or there is some sort of vision changes being observed. The heart disease, nerve system, or blindness. This could be possible because of the diabetes where you have a high blood glucose. And important is, once you enter into the diabetic condition, the chances of the death is increased 50% higher than the non-diabetic patient. Okay, so always you are in a, you can consider one particular, you can consider is a bracket condition that if your body is having a high blood glucose value, that it could lead to a many subsequent complications, and because of that, the chances of the death is almost increased the 50% more. Now, before actually discussing about the glucose measurement and glucose control, we should first understand the type of diabetes. What are the different category of the diabetes which is being observed? Okay, so first is the type 1 diabetes, and there is a type 2 diabetes, and third one is the gestational diabetes. So third diabetes is a temporary diabetes which is being observed during the pregnancy period of the woman. Okay, usually once the pregnancy is over, then this diabetes condition will be disappeared from a woman. But definitely woman has to take care further so that they cannot enter into either of these two main categories, type 1 and type 2 diabetes. Okay, now type 1 and type 2 are the main diabetes category that is being observed for a diabetes patient. Okay, now what is the diabetes? As I said that if I consume a sweet item, then it doesn't mean that I will end up into the diabetic patient. Okay, that is totally wrong. For the diabetes, the pancreas will play a very important role. Okay, so many times you have heard from a doctor that if you say that I am not a diabetic, then they used to say that your pancreas is fine. Okay, so health of the pancreas is very important in your diabetes. Okay, now if inside your pancreas your body is able to generate the insulin adequately, okay, then you are the healthy person, you are a non-diabetic condition. Okay, if your pancreas is not able to generate or not sufficient insulin is being generated, then it is type 1 and type 2 diabetes. See, once we have a consumption of the food item, then definitely inside the body there will be generation of the glucose. So that we consider as the glucagon hormone. Okay, so that is what by nature is being generated. by having a consumption of a food item. Now, in order to neutralize it, inside the body, the pancreas will generate the insulin. Okay, and that insulin is responsible to neutralize the excess amount of the glucose level. Okay, so if I consume any sweet item, then definitely the glucose concentration will be higher. But at that time, my insulin will neutralize that. And the pancreas should generate the adequate insulin so that the higher glucose value could be neutralized with that. Okay. Now, if a pancreas is not able to generate any insulin inside the body, then that condition is type 1 diabetes. That is, we used to term that T1DM patient. That is a type 1 diabetes mellitus patient. Okay. And that is very serious because now your body or pancreas is unable to generate any insulin inside the body. So first thing is if you consume any food item, then glucose will be generated. And if you eat a sweet item, then it is more dangerous because over there the concentration of glucose is very high and your body is not actually generating any kind of insulin over there. Okay. So that's why a type 1 diabetes is more critical condition. They used to take the directly insulin dose before having a food. Okay. For a type 1 diabetes patient, many times you have observed that they used to take the injection before having a particular food item because their pancreas is unable to generate the insulin. Nothing insulin is being generated inside the body. Okay. Why? In a type 2 diabetes, that is, you can consider some sort of mild diabetes condition. Okay. Where your pancreas is able to generate the insulin, but it is not adequate enough. Okay. So insulin is being generated inside the pancreas, but it is not able to neutralize all the excess glucose which is being generated inside the body. So for that, you should take a medicine. And that medicine also that we used to take before having a food item. So that's why a diabetes patient is used to take a medicine before having a particular food. Most of the time we used to take the medicine after consuming the food item. But in a diabetes, you need to actually take a medicine before a food item. Why? Because that medicine is nothing but help you to have a generation of the insulin inside the pancreas. So once you consume a food item, then at that time, whatever the glucose is being generated, that could be neutralized with whatever the insulin which is already being present inside the body. Okay. So that is the type 2 diabetes where the insulin is insufficient, but still through a medicine, it can help us. But in a type 1 diabetes, there is no remedy. You need to take insulin directly only because your body is not generating any insulin. Now, continuous glucose monitor. Okay, so that is also a very important concept. Now, when I say continuous glucose monitoring, that means I want to monitor a glucose value throughout the day. Okay. So, possibly, as I said, that 4 times in a day, if I want to measure, then for that also there has to be some support of a technology. Whatever the present technology where you need to pinch inside the body and take out the blood, that is not the viable solution. That is not the long-term solution that could be sustained. It will create a trauma into a patient. And as the diabetes comes with the age, okay, so once you enter into the 50 and 60, so at that time, pinching inside the body is also considered to be very painful. Okay, so that's why you need to think about some sort of a smart healthcare solution which support a continuous glucose monitoring concept. So for that, we should adopt a non-invasive solution. Okay, now whatever the solution which we have discussed, it is an invasive. Okay, so in an invasive solution, you need to pinch inside the body and you take out the blood component from your body, and then you measure the glucose. Non-invasive, where from your body surface only, you would be able to measure the body blood glucose. Okay, so now for that, you need to identify a reliable technology also, so that you can able to measure the body blood glucose from the surface only. Okay, something where you want to measure some sort of health parameter from the outside the body, which we consider the non-invasive. So for that also, definitely the precision would be low. Okay, because something which is happening inside the body, that you want to measure it from your outer body surface. Okay, so non-invasive technology is always suffering from accuracy. Okay, so we need to think about the reliable technology, so that we can solve the diabetes management problem efficiently over here. Okay, so we have developed the non-invasive solution where from the body surface only you would be able to measure the body blood glucose. Now for that we have used the optical detection method. Okay, so when I say optical, then optical is basically related to the some sort of light. Okay, so now we need to identify a particular light source which actually help us to measure the body blood glucose. Now, when we say optical source, then it could be a laser, it could be a LED, or it could be any kind of other source which is available, which is emitting a light. Okay, here we have used a LED. Okay, because LED could be less harmful component of the optical source, which actually help us to measure the body blood glucose value continuously throughout the day. Okay, so here the optical detection measurement technique is being applied to measure the non-invasive body blood glucose. Okay, now for a glucose measurement, okay, so glucose is nothing but a combination of carbon, hydrogen, and oxygen. Okay, that is the CHO bond is usually observed inside your glucose molecule. Okay, now when a particular light source is emitting a light, okay, then that light could be absorbed by that particle, or it could be reflected by that particle, or it could be scattered by that particle. Okay, so when a particular light is being incident onto a particular particle, then it could be absorbed, or it could be reflected, or it could be scattered. Okay, so these three phenomena we have considered while we are actually trying to measure a glucose value non-invasive. Now, for that we have done some experiment. Okay, now we have observed that we need to go for a optical detection measurement technique to have a non-invasive glucose measurement. So for that, you need to identify a correct source. Okay, even though we decided LED, but LED of which specification? Okay, so LED will have a different wavelength, but I need to observe or identify a correct wavelength, which actually help me to identify the body blood glucose. Okay, now in order to identify the exact wavelength, we have done some experimental analysis. Okay, so we have used a spectrometer. So spectrometer is available at our MRC lab. Okay, so Materials Research Center we have inside our MNIT college. So where we have a spectrometer. So we have observed the spectrum through this spectrometer for a different sample. Now what are the different samples that we have considered? So what we have considered? We have considered a glucose powder. Okay, so glucose powder form is easily available at your medical store. Okay, or even the glucose bottle also you can purchase. Okay, so what we have done is first we have observed a spectrum of the glucose powder. Then we have observed the spectrum of the glucose water. Okay, so we have actually diluted the glucose value 5 gram, 10 gram, and 25 gram into 100 ml of water. Okay, and the same thing we have done through the glucose bottle also. The glucose bottle is also having a different concentration. At 5% concentration, 10% concentration, 25% concentration. So that glucose bottle is also available in the market. Okay, so we have taken those sample. Okay, one is a clean water and then a diluted glucose value inside the water. Okay, 5 gram, 10 gram, 15 gram, like that. Different concentration of the glucose is being considered for the water, and that sample we have observed, and we have observed the spectrum. Okay, and through the spectrum we have identified that at two particular wavelengths, the glucose is very sensitive, 940 and 1300. So that we have considered to have an exact glucose detection. We should have this particular two wavelength optical source. Okay, so the device that we have developed through our experimental analysis, that we term as a IGLU. IGLU stands for intelligent glucometer. Okay, so initial version of the intelligent glucometer, whatever we have developed, that is the first version, that we term as a IGLU 1.0. Okay, so over here what we have done is we have used the three sensors. Okay, if you just observe it over here, then there is a three sensor is available. This is my first sensor, this is my second sensor, and this is my third sensor. Whatever the yellow one is there, these two sensor is for the absorption. Okay, so 940 and 1300 absorption we have observed. Okay, and this is third sensor, which is nothing but a reflectance. Okay, so reflectance of 940 is only considered. Okay, so 1300 reflectance is not actually adding any improvement of the glucose estimation. So that's why we have dropped it out. So we have used the three sensor. Okay, so 940, 1300, these are the two possible wavelengths. And for that, we have used the absorption and reflectance. Okay, there is no role of the scattering that is being observed over here. But absorption for the two wavelengths, 940 and 1300, definitely play a crucial role. And the reflectance of the 940 is also actually improving the accuracy of the glucose some extent. So we have used that particular sensor also. So this three sensor is basically developed. Then you just observe there is the acquisition module which is being developed by us, and this is the Arduino module. Arduino value is just to actually to have some sort of processing or having some sort of downloading of the data. Okay, so from these three sensors we are getting the sensor value. Okay, and that we are calibrating against our reference blood glucose value. Our reference blood glucose value for our first version, we have used a self-monitoring device. Okay, so self-monitoring device is basically used as a reference, and we have calibrated our this three sensor value against this reference value which comes from the self-monitoring. Okay, and through which we have established one regression model. Okay, in the first class we talk about it. What is regression? When I want to identify a glucose value or when I want to predict the glucose value, then the regression model has to be used. Okay, if I want to classify whether a patient is diabetic or non-diabetic, then there is a classification problem. But if I want to predict the glucose value, then it is a regression problem. Okay, because glucose value is continuously changing inside the body. So there is a continuous change variable which I need to predict. So for that the regression model is. So regression model is being established. Okay, and then we are finding the error analysis. So through this regression model, we have estimated glucose value and we have a actual glucose value which is being measured through a self-monitoring. Okay, and we are actually finding the error analysis. Error analysis, that means difference. So if I am having a X value which is being predicted and the Y value is being observed as a reference one, X minus Y is the difference. Okay, so that difference is basically defining. Ultimately, I wanted the difference should be minimum. Ideally, the difference should be zero because whatever my prediction should be matched with the reference blood glucose value, which I consider as a self-monitoring. Okay. So for this measurement, performance measurement, we have measured a different parameter MARD, average E, MAD, and RMSE. Now, this is the spectrum which is being observed out of the spectrometer. Okay. So I told you that we have used a spectrometer to just observe the spectra. So we have actually observed the spectra of the glucose powder, your clean water, and inside the water, 5% glucose concentration, 10% glucose concentration, and 50% glucose concentration. Okay. And the spectra is being observed. तो अगर आप देखोगे तो स्पेक्ट्रा में दो जगह पे आपको पीक मिलेगी. So these two peak is being observed as 940 and 300. Okay, around 300. So these two wavelength is being considered over here. So this is our experimental setup where this is the acquisition model which we have developed. We need to insert the finger like this for all three sensors. Now through which you would be able to measure the body blood glucose value. Okay, and as I said that we have used the absorption and reflectance spectroscopy for 940 and 1300. So typically absorption and reflectance is 940 and your reflectance at 1300. Okay. So 3-channel data is there for all these three: 940 absorption, 1300 absorption, and 940 reflectance. So this 3-channel data is there. So this 3-channel data is being taken out as from this particular finger. Okay, and that is being, this 3 sensor data is being applied to a regression model, and that regression model will help us to get the some sort of accurate prediction. Now self glucose monitoring is possible with such kind of non-invasive approach. Okay, so ultimately I need to wear 3 sensors on a 3 different fingertip, and through which we can observe the blood glucose value. The good thing is this device, which we term as the IGU, intelligent glucometer, is also being connected through a IOMT. Okay, so whatever the data which is being collected from a sensor, that is being stored at a cloud as soon as possible. So it is something like that. I am taking now medicine. Now, after medicine, whether I am able to control my body blood glucose value or not. Okay, so previously my glucose value, let's say it is a 140. But definitely by consuming the medicine, I expected it should be near to 100. Okay. So that is to have a controlled diabetic patient. This glucose measurement is basically playing a very important role. Now this is the basically novel contribution where you just observe that there are 3-channel data. Channel 2 and channel 3 is nothing but the 940 reflector and absorption. And your channel 1 is nothing but the absorption. Here you have a microcontroller, then there is a regression model, and through this regression model, you are estimating your blood glucose value. Okay. So this is the way that you can wear a 3-finger data, and through which you can able to measure the body blood glucose value. Now, there is a concept of the serum glucose. Okay. Now there is a concept of the capillary glucose, and there is a concept of the serum glucose. Now, what is capillary glucose? Capillary glucose is a glucose value which basically measures a glucose from your whole blood sample. Okay. So whenever you measure a blood glucose value from the self-monitoring device, okay, so that we purchase from the market and where we use the strip and there is a some launching pad and we insert that strips with the blood sample inside the device, then I am using a whole blood sample to measure the body blood glucose value. So that will allow us to measure the body blood glucose value, which we term as a capillary glucose value. Okay. However, whenever you visit the laboratory, okay, so from the laboratory, you would be able to measure a serum glucose value. Okay. So what happens when you give a blood sample at a laboratory, then they will collect the blood sample. Then they will put that particular blood sample into a centrifugal pump. So that centrifugal pump, what we are discussing, that centrifugal pump is basically diluting, or you can consider a separate out the heavy particle of your blood, and there is a serum particle. Serum will looks like a liquid, like a water. Okay, and all the heavy particle is settled down at the bottom. So whatever the water looks like sample, which we consider as a serum, that serum is then further being placed into a one particular, you can consider a device through which you can able to measure the body blood glucose. So serum glucose value is according to the medical regulation is a more closer of your body blood glucose. Okay, because that actually helps you to get the exact body blood glucose value inside the body. However, a capillary glucose, where we use a whole blood sample, which will not help you to get the exact body blood glucose. Okay, so serum glucose value is, you can consider a more important, which actually helps us to get the more closer body blood glucose value of your diabetic patient. Okay, and serum value is always a more accurate and lesser, right? A capillary glucose value is, you can consider a sometimes random, and it gives you a higher value. Okay, so our second version of iGlu 2.0, where we are considering a serum glucometer, where we have calibrated the device against the reference value, and that reference value comes out from your laboratory, where the serum glucose value is being measured. So we have calibrated our sensor value with the serum glucose, and then whatever the model which is being generated, which actually help us to get the prediction of the glucose value, that we consider as the serum glucose. So that model now predict the serum glucose value of your body. Okay. Now, in order to collect the sample or measure the body blood glucose value, we have used the different samples from a different patient. So you have a healthy patient, you have a diabetic patient, you have a pre-diabetic patient. So all these different category person are being recruited to collect the data. Okay. Now I will show you the working demo of your our blood glucose measurement device. Now, this whatever the solution that I want to define, a glucometer, that is now reduced to a single sensor. Okay. So when we started the collecting the data from the patient, at that time, we got the feedback that the three sensor where you need to occupy three fingers. Okay. It is slightly difficult in comparison process. Okay. To make it simple one, what we have done it, we have only single sensor out of three, and that is the 940 absorption. 940 absorption is the main contributor to measure your body blood glucose value. That is being used over here in this particular demonstration. So you just observe this particular video. I hope that video is visible. So here you just observe that the finger is being inserted inside the device. Okay. Now by inserting the finger inside that device, the sensor value is being generated. Okay. That sensor value, what is being generated at your terminal, that you are plugging into Excel file. Okay. The sensor value is being plugging into Excel file, and that Excel file is being imported in this particular regression model. Okay. So from this regression model, you will get the prediction. ये prediction अगर आप देखोगे, तो अगर आप देखोगे prediction यहाँ पे है, तो हमने 3 regression model यूज किए हैं, ठीक है? Random forest, decision tree and Gaussian. तो आपका random forest से 107 आ रहा है, आपका Gaussian से 87 आ रहा है, और decision tree से भी 87. So from this 3 regression model, we are getting 3 different prediction. But if you consider a majority voting, okay, of your regression model, then 87 we can consider, because 3 out of 2 is predicting 87. So we consider that 87 mg per dl is the exact blood glucose value of that particular patient. Now that glucose value we have actually being compared with the standard FDA approved device. Okay, so this is basically AccuCheck device. AccuCheck device is the popularly available and through which we have observed 93. So initially it was 87. Through AccuCheck we observed 93. This is doctor trust device. This is also second device where you are getting 90. Okay. So what is the conclusion? That one device which is giving 90, another device it is giving 93. While our predicted model, which actually helps to get the serum glucose, with the glucose value is being observed 87. So that actually consider that we are getting almost 95% accuracy. So 90, 93 against the 87, which is the actual value. Okay. So this is a glucometer. Now, whenever you develop a particular glucometer, then you need to compare that result with the Clark error grid analysis. So Clark error grid analysis, you can consider a benchmark circuit which actually help us to validate our device against the clinical standard. Okay. So if you observe that there is a zone A at the middle, then there is a upper B and lower B, that is UB and IB is being defined. Okay. Similarly, here UB and IB is being defined for A, then UC and IC. Okay. Now, what we are trying to do, we are trying to measure the body blood glucose value. Now, if my estimated blood glucose value, which comes at the y-axis, and reference blood glucose value, which comes at the x-axis, then x against y plot is being provided. Now, if the value is matching, then I will get some sort of linear curve. Okay, if there is a linear curve of matching of estimated blood glucose value against the reference blood glucose value, then the value lies in a zone A. And if it is residing in zone A, then I consider that my device is clinically accurate. Okay, if there is a deviation, slight deviation, okay, maybe 15-20% deviation, then this is basically zone B. Then you have a zone C. Okay, which basically consider that you require a correction, and your D and E zone is you consider it a failure and error zone. Okay, that means whatever the concept you have applied, that is not at all useful, and it is not basically considered to be a clinically validated concept. So if it is B and C, then also it's okay. Okay, where you can apply some sort of correction and then you can improve the accuracy and you can come into the zone A. But ideally, we should have a reading in zone A. Okay. Now, when we come up and we have done the experiment of the 350 patient, then from 350 patient, 330 patient reading comes in zone A. Okay. And remaining 20% or 20% data is residing in B and C zone. Okay. So this itself suggests that our device is clinically validated. So whatever the iGlue device that is being developed by us, that is clinically validated, it could be useful for the glucose measurement purpose. Okay. Now here you just observed that we have actually compared the result in terms of the error measurement with the other similar work where we have actually outperformed in every other. Okay. So next is a diabetes management. Okay. Now before jumping to a diabetes management, possibly we can have a 5-minute break. Okay. So because we have today a long marathon of the 4 hours, so I thought that maybe after every 1 hour we could have a 5-minute break. Okay. So let's take a 5-minute break over here. And meanwhile, if you have any doubt right now, whatever is being covered, you can type in a chat box. Okay. So that I can resolve it right away. Okay. So we will be meet again at 5:10. Okay. Currently it is 5:05. So we will meet at 5:10 after a 5-minute bio break. Okay. Yes, any doubt you have, whatever is being covered till now?
पॉपअप रिमूव करके क्योंकि रिकॉर्डिंग में ये पता चला
ये वाला? करूं नहीं?
नीचे स्लाइड कर
नहीं हो रहा है, कुछ भी नहीं हो रहा है। इसलिए मेरा सिस्टम है
होगा आप ही से ये पीपीटी
Okay, participant possibly. Presentation.
ये
Okay. Okay, I think थोड़ा स्लाइड ही कर रहा है, तो जा ही नहीं रहा है। वैसे तो क्या कोई टास्क है ही नहीं, उसको मैं कैसे निकालूं, स्टेप से भी नहीं निकालूं। ओके, एनीहाउ, ठीक। So basically, automatic insulin drug delivery model. Okay, that means ultimately we have discussed that type 1 diabetes patient is more critical condition of diabetes, where actually your pancreas is unable to generate any kind of insulin. Now, since your pancreas is not generating any insulin, you need to insert a direct insulin inside the body. Okay. So for that, maybe we can have an insulin pump where there is a pre-insulin is being stored, and from that stored insulin, you inject the insulin inside the body whenever it is required. Okay. Now, as I said that glucose is keep on changing inside the body. So according to that, definitely the requirement of the insulin could be also changing inside the body. Most of the time, what we used to do, we used to take the insulin which is being prescribed by a doctor, and that dose is fixed. Now, that's not true always, because according to your activity and according to your diet, your body blood glucose value is different. And if a different blood glucose value, then in order to take the control diabetic, the insulin amount is also varied. So now what we have done it over here, that whatever the eye glue, that eye glue is basically integrated with the insulin pump. Okay. So whatever the glucose value that is being stored at the cloud, and under the supervision of the doctor, the insulin dose is being injected inside your body. So this will provide some sort of closed loop solution. Okay, and that is very much important in a smart variable technology. See, detection of the disease is definitely a very important, but that will not resolve the problem in a smart healthcare. So if you detect a disease, then I consider that is a half solved problem. Okay, because once you have detected a disease, then you need to also provide the remedial solution. and that I consider as smart healthcare. Okay, in a smart healthcare, always we need to think about the closed loop solution. So that also I possibly request all my students. Okay, that you don't only identify the problem. Identification of the problem is the first step, but definitely you need to think about of solving that problem, and that's what we are trying to do it over here. So if you identify a diabetes or type 1 diabetes specifically, then you need to have an insulin consumption. So that insulin consumption will be controlled by according to your present blood glucose value. So insulin pump is being integrated at the cloud with the iGlue, where iGlue is continuously helping to track your glucose value. And whenever a glucose value, let's say that it is increasing to 150, then appropriate insulin doses is being injected inside the body. Okay. So that is what we have discussed over here. So that is a development of the artificial pancreas system. Okay. So artificial pancreas system is pretty much important. Okay. That is the concept where basically you are creating a glucose insulin model inside your insulin pump, and that insulin pump now decide that what is the exact amount of the insulin is required. Initially, maybe you can have under the observation of the doctor, and doctor will give you the exact indication that what amount of the insulin is required. But ultimately, we want that should be independent of somebody, that automatic insulin delivery has to be done. So for that, you need to create a one particular glucose insulin model inside that particular insulin pump. So inside this insulin pump, this model will decide that what is the exact amount of the insulin has to be injected according to the present glucose value. So that is the artificial pancreas system. So this is glucose insulin model that we already talked about. Okay. So alpha cell inside the pancreas is generating a glucagon. Glucagon hormone is nothing but the glucose. Okay. While a beta cell is actually responsible for an insulin. Okay. So this alpha and beta cell will play a very crucial role for a balance of the glucose and insulin inside your pancreas. That is very much required. Okay. So we have developed a glucose insulin framework also, which we have discussed, that where we have developed an artificial pancreas system where we have actually deciding the exact amount of the insulin which is to be injected inside the body. Okay. So this is the just a framework. Okay. Where specifically for the hyperglycemia condition. Okay. So if we enter into the hyperglycemia, see, if you are on normal glucose or hypoglycemia, so there is no need to have any kind of insulin. But if it is a hyperglycemia where body is having a high blood glucose value, then possibly you need to think about of having a role of the insulin pump where a glucose insulin model is being developed as an artificial pancreas system, and that artificial pancreas system will help us to actually inject the insulin inside the body, and again we will measure a body blood glucose value. Observe that if it is below hyperglycemia stage, then we no need to go for insulin. So this loop will exist till I get below the hyperglycemia, or ideally I should go for a normal glucose rate. So if it is a normal glucose rate, then there is no need to go for any insulin injection. But if it is in hyperglycemia, then I need to keep on injecting the insulin inside the body till I get the normal blood glucose value. So that simulation is also, we have done it on a 4 real subject. Okay, so there is a UA Padova simulator which actually will help us the similar thing. But we have developed a model into a MATLAB where we have tested on a 4 real subject, and where we have observed that we will be able to control the body blood glucose value of the patient. Okay. Now we are moving towards the second case study. Okay. In a second case study, we are basically discussing about the upper lip prosthetic control. Okay. Now we consider hand is a very important organ of your body. Just think about the daily activity that you are performing with the help of hand. Now, a person which is not having a hand, okay, that we consider as the upper limb prosthetic amputee. Okay, so upper limb amputee, sorry, so upper limb amputee who is not having a hand, and how they can survive in this particular world to perform the daily activity. They cannot ask a helper to do every task of their daily activity. So now for that, what could be the solution? You can have some sort of prosthetic hand that we consider as a robotic arm. Okay, and that robotic arm could be controlled from your brain. Okay. Now we have already discussed in last week that when I capture a signal from your brain, then it is EEG. Okay, where I observe a brain activity at your head scalp, then it is EEG. But if I observe a brain signal at your muscles, then it is EM. Okay, here we have developed a solution through EMG because EMG acquisition module is somewhat simpler and cost effective than EEG. EEG acquisition module is little bit of complicated and it is having a higher cost. But EMG, you can simply place the electrodes and through which you can actually observe the signal very well. So we have used the EMG based prosthetic control over here. We have developed. Okay. So EMG based prosthetic control will help us to get the functionality like a real arm in an upper limb amputation. Okay. So these are the basically you can just observe that robotic arms are there, which actually help us. So ultimately the flow is that whatever the EMG signal, from that you extract the feature and you identify the activity. Okay. So I will identify the activity that from this particular robotic arm, I want to perform this much activity. So dose set is also basically defined as activity of daily life, that is ADL. Okay. So that is simple like a hand opening, hand closing or grasping of the some simple item. So that we consider as a your activity of the daily life, that is the ADL. So that we have considered over here. So according to the number of activity, we define the classification model. Whether it is a 3-class problem, 5-class problem. If we increase the number of activity, then the problem will be entering into the more number of severe classes. So we have used the surface EMG. It was but obvious that is a we can consider pain-free method through which I can capture the EMG signal. Okay, so we have used the surface EMG, and this we have talked about that how EMG is being generated. So ultimately, through a brain, the signal is traveled through your spinal cord, and through which it will reach to your muscle fiber. So here at this junction, we are actually measuring the potential of EMG. So this is the flow. Okay. So whenever you have a prosthetic hand to an EMG signal, then we consider it a myoprosthetic. So this myoprosthetic where through a muscles you are capturing the surface through a surface electrode you are capturing the EMG signal. Then it will go to a pre-processing step. Okay, where you go for application, filtering and ADC. So identify a signal in a proper EMG range. Then this is your main ML model. Okay. So this machine learning model will help you to identify a particular activity, and according to the decoding of particular activity, you supply your signal to your robotic arm, and robotic arm will perform the exact activity. Okay. So I am just demonstrating one video where you will see some solution which is being developed by us in our laboratory for a prosthetic people. Now, if you just observe the video, okay, so we have developed some sort of deep learning framework, okay, where the robotic arm is being controlled by brain. Okay, so this is the subject. I have used the healthy subject by me only, okay, because to do the experiment on our amputees, we require some sort of ethical clearance, and it would be very difficult. So we have done the experimental at our self only. So you just observe that some electrodes is being placed on my forehead hand. Okay, from the forehead, the signal are being captured. Okay, and that signal is being acquired by a acquisition module. That is a red color acquisition module that you just observe. Okay, this EMG acquisition module, and that EMG acquisition module will capture the signal, and that signal is being plugged in to your computer. Now inside the computer, your ML algorithm will work. Okay, so your machine learning algorithm will work and it will decode the activity. Okay, so according to your muscle movement, you need to decode which activity has to be performed, or brain has initiated which particular activity. Okay, and that activity is being identified, and then according to that, the command is being sent to a robotic arm through a Arduino board. So there is an Arduino board is there. Okay, that Arduino board is sent a command to a robotic arm, and robotic arm will perform the activity accordingly. Okay, so here we have identified a few activity of the daily life where I have observed that hand open, hand closing, and grasping of the simple bottle. So hand open and hand close. Now we just observe my hand and robotic arm. We just observe that I am opening my hand. We just observe that white robotic arm is opening in the hand. I am closing my hand. So just observe that robotic arm is closing the hand. Again I am opening my hand. So robotic arm is again opening the hand. Okay. So here you just observe it that then I am just grasping the bottle. Okay. So if I grasping the bottle and make my hand movement, then that robotic arm will also have a similar kind of finger movement. And if any kind of bottle is placed in front of that, then it will pick up them. Okay. So this is a solution which is we have developed it at our laboratory, and actually we have supplied it to Bhagwan Mahavir Viklang Kendra. That is just adjacent to our college. Okay, where they are using this solution very effectively. Okay, so that deep learning upper prosthetic arm what we have developed, that is being compared with the various other algorithm. We observe that our is the best performance out of all. Okay, now training is also very important. Okay, we have initially done the experiment on a healthy patient, but then we have also recruited the few amputees. Okay, now for amputees also the capturing of the data acquisition is very important. Okay, so for that usually we used to have a visual feedback system. What is the visual feedback system? That you have one mirror which is being placed between the two legs of the amputee, and consider that amputee is not having a left hand. Okay, so left hand is the robotic arm. Okay, now that robotic arm, so ultimately your brain has to generate those signals in order to initiate a command to a robotic arm. Because if your brain is not generating a signal, then means you will not able to get it through a EMG. And once you decode it, then you can supply the command to a robotic. So generation of the signal is also very important. Okay, one way is you can do it play some video in front of the amputee people, and then your brain will generate such kind of signal inside it, and then you capture those. Another is whatever is being presented over here is a visual feedback system. Okay, where you place a mirror at between two legs. Okay, and whatever your real arm, so left hand is your robotic arm, right is your real arm. So you do a movement of the real arm and see at the opposite end from a mirror. So now mirror will perceive that your left arm is having a movement. Okay, now for every arm activity, there is a different impression in your brain. We have seen in the EEG, there is a left hemisphere, right hemisphere. So there will be a different impression which is being observed for a left hemisphere and right hemisphere when I want to do a movement of the left arm. So through this visual feedback, what we are trying to make the perception inside the brain that this robotic arm or left arm is doing a movement. Okay, so brain will create that kind of perception inside the mind, and it will generate the signal accordingly, and that signal is being captured by your EMG sensor, that is being decoded through your ML algorithm, and whatever the activity which is exactly being identified, according to that you send the command to your robotic arm, and that robotic arm will perform the exact activity which is being initiated by a brain. Okay, so that is a setup which is being developed. Okay, so you can also go for a real-time EMG development. So that is also being done by us, where we have actually done a feature extraction part, which is very important. Okay, it is time-consuming process also, because you need to identify the important feature out of the feature, or first of all you need to select the feature. From the selection of the feature, you need to identify a feature and feature with the highest weight, and those feature engineering will require lots of time. So that is being implemented on FPG. Okay, and then we have observed the performance. Now similarly, Q activity is being implemented on an arm. Okay, that is the microcontroller, and then we observe the performance. So there is a simple software means software approaches means I am running on a system, whatever the computer system where I am running the algorithm, and then I am measuring the performance. So that is basically blue color. If you just observe it, then there is a slightly green color, which is the hardware HLS. Hardware HLS, that means pure software approach, where I am actually implementing on a hardware through HLS. That means whatever a C code or whatever the Python language, that I am converted into the VHDL Verilog, and then I implemented on a FPG. So that is the hardware HLS, and there is a pure VHDL approach. Okay, where everything is being written by me and implemented on FPG. So it is, you consider as a full custom, because when you use the HLS model, through HLS model, the conversion is possible. Your C code can be converted into the value of VHDL, but the syntax is basically machine interpreted. Okay, and it is not the exactly the optimized code. But whatever you have written by your own, okay, that is a yellow bar. That is the most optimized code. And if you just observe the duration, that the duration of the yellow one is much better. Okay, that is a much efficient. That means much lesser than your software and software HLS. Okay, so this we have done. Now another application where we are working is mental disorder detection. Okay, so mental disorder is also creeping up very gradually from past few years, and after the post-COVID, the impact is going basically observed substantially. Okay, so the depression is one of the very important mental health problems. Okay, so currently 1 out of 5 people are suffering from a depression. Okay, and definitely we need to think about some solution. If we just observe the suicidal case in India due to depression is larger compared to a global. Okay, and woman is having a higher tendency of the suicidal thoughts than a man. What is the global population of the depression? Okay, so according to the WHO, okay, so means around 80% of the people, okay, so that is a 3 million global people are suffering from a depression. Okay, and if we talk about the India, then 1 out of 20 is suffering from a depression. And currently we have observed that the depression is very prominent in a student's life. Okay, being a NIT, okay, we have observed that many students in the earlier first year and second year, they are suffering from a depression. Okay, so that problem has to be solved. Okay, so for that, various solution is there. So Apple has developed one solution where there is a watch. Now that actually helps us to measure the mood of a patient, okay, or mood of a person. Okay, whether it is having a depression or anxiety or something like that. Okay, there is another solution which is being developed by University of North Texas people, where they are having a temperature sensor to measure the body temperature. Physical activity is being measured through accelerometer, and there is a humidity sensor to observe the sweat analysis. Now this 3 sensor value is being plugged in, and from this 3 sensor value, they are able to identify whether a person is a stress or a neutral. And if a person is a stress, then what is the stress value? This 3 sensor is a very easily available in the market. Okay, temperature sensor, humidity sensor, and a accelerometer, and through which you can able to identify the stress level inside the person. Okay. So treatment of the neurological disorder is very important. Okay. So there are the different biomarker is there. The people are going for a CT scan, people are using for a MRI image, but we observe that EEG is the best biomarker. Through EEG, you can identify the neurological disorder, any kind of. Depression is one of them. Okay. Even we have identified epilepsy, schizophrenia with the help of the EEG signal. Okay. So EEG we have already discussed, so I am skipping it. So one of the solutions that we have developed through a deep learning is a deep HNN model. Okay. So depression hybrid neural network. Okay, where we have used the LSTM and CNN model, that is a hybrid model, through which we are able to identify the normal and depressed people with 99.99 accuracy. So it is almost 100% guaranteed that through this model you can identify the person is depressed or not depressed. Okay. Now there is another variable solution that is in terms of the cap. Okay, that is being developed. Okay, where you can observe your EEG pattern, and that EEG pattern is being stored at a cloud. At the cloud, you can apply some AI/ML algorithm, and then possibly you can identify whether a person is being depressed or not. Similarly, schizophrenia. Schizophrenia is nothing but some sort of hallucination. Okay. Somebody is not existing in the world, but still you can see the existence of that people. Then that is a schizophrenia. The schizophrenia patient is also very huge, 24 million. That is also very large. Okay. So for that also we have developed a solution in terms of the cap, where through a EEG you can identify the schizophrenia patient. Okay. I'm just keeping it right now because we don't have a time, but this is a such kind of variable solution. Schizophrenia cap. Okay, that is a basically variable cap to detect the schizophrenia. Okay, so cap is something like this, where you have an indicator by green and red. Green indicates that patient is not suffering from a schizophrenia, where red is indication of suffering from a schizophrenia. So there is a edge processor where the ML model is being developed over here inside this particular cap only, and through which you can able to identify the solution very easily. Now, epilepsy is also one of the very prominent problem. Okay, where you will observe sudden alteration in the behavior. Okay, so epilepsy and seizure. So basically, epilepsy is a recurrent episode, and seizure is the, you can consider the instant where this occur. Okay, so recurrent seizure is nothing but the we can consider the epilepsy. Okay, recurrent episode is being observed in a seizure. Now for that also we have developed a variable solution. Okay, so we have observed in a literature that epilepsy is having a close relation of the glucose value. When a person enter into the hypoglycemia state. What is hypoglycemia? Where body is having a lesser glucose value. Okay, so at that time, the blood cell is not able to get the proper glucose for a functioning. So your brain cell, okay, so your brain cell is not able to get the proper glucose as well as oxygen. Hence, it will lead to a epilepsy episode. Okay, so that hypoglycemia, that is a lesser glucose value, and hypoxia. Hypoxia is a condition where your body is not having enough glucose value. So that you can measure with the simple your pulse oximeter. So pulse oximeter can measure the SpO2 value. So we have observed that if your SpO2 value is less than 90 and your glucose value is less than 50, then there is a chances of having a epilepsy. Okay, because epilepsy is a recurrent episode. Okay, so once a person is basically encountered with the one epilepsy episode or one seizure episode, then there is a chances of the second and third also. So for avoiding that recurrent episode, we have developed a device which we term as a glucoximeter. That is also being patented. Okay, and we grant the patent for that. That glucoximeter, that means it measures the glucose as well as the SpO2. So it is working as a glucometer as well as a pulse oximeter. So this method, this solution is being developed, okay, with the photodiode, that whatever the way that we have developed a glucometer. So that glucometer 940 nanometer wavelength is basically considered, and 660 and 800. So that is basically come from your pulse oximeter. So pulse oximeter भी similar ये means principle पे काम करता है, ठीक है? So that we have incorporated and through which we have able to measure. Now final case study that we want to cover it right now is a hypertension. Okay. So elevating the blood pressure value is also having the correlation of the cardiovascular disease. Okay. तो जिनको भी हार्ट का प्रॉब्लम आता है उसका बेसिकली मेन प्रॉब्लम है आपका ब्लड प्रेशर. So that blood pressure is basically nothing but the hypertension. So that we have measured it through a PPG. So we have basically done a correlation of the PPG with the cardiovascular disease. Okay. So currently cardiovascular disease is being identified through a ECG. And though we have some sort of ECG portable machine, but definitely they are not that much of user friendly. But PPG is basically works on your means optical measurement. Okay. So through the PPG, you can easily identify the footprint of the some sort of volumetric change in your blood through a PPG signal. And through this change, we can correlate that whether a person is having a CVD problem or not. Okay. So basically hypertension and CVD is having a close relation. Okay. So hypertension is again a chronic illness. When I say chronic illness, then continuous tracking is required. And continuous tracking, you need to do it with the variable device. Okay. So it is something like that, the critical parameter I want to measure. But it is not necessary that I need to be admitted in the ICU. When I say ICU, then ICU is a condition where you need to measure a critical parameter of the patient continuously. Now we want to adapt such practice in our daily life through a variable device. And that's what we consider as a smart variable healthcare device. Okay. So here also we have used the PPG signal, which is the optical, which actually help us to change the footprint of the volumetric change in a blood. So this is a very non-invasive and low-cost device, which actually help us to get the reliability of the CVD. We have used the PTB Excel dataset, okay, where the blood pressure dataset is available for a 209 subject, where 657 instances are there. So definitely the multiple instances being considered. So ultimately the 3 instance is being considered for each subject. Okay, so that's why the instances are more for your blood pressure from your 219 subject. Okay, where we have applied the feature extraction, where we applied the time domain, frequency domain, and some sort of demographic features. Okay, and then we have applied some sort of classification model to a LDA, KNN, SEM, random forest, and Gaussian naive Bayes, and through which we are able to classify the CVD patient and non-CVD patient from a PPG with a very good accuracy. Okay, so this is the basically a table where you just observed it with the extracted feature and through only PPG, whatever the extracted PPG through which we are trying to identify the footprint of the CVD patient. And the second table is through an extracted feature. So through extracted feature, you just observed that accuracy is being improved drastically. Okay, so this is similarly for the different stages of the CVD. Okay, so or I should say hypertension. So that is the normal pre-hypertension. Stage 1, that is the mild hypertension, and stage 2 is the severe hypertension. Okay, and we have compared the work with the other. Okay, now this stress detection variable device, I am skipping it because That on anyhow I have taken it from a one particular paper. Okay, but stress detection is also very important. And it is the difference between the depression and the stress. Stress is you can consider a temporal occurrence. Okay, but if that stress is occurred over a period of time, then we can end up in the depression. And depression is require a substantial longer treatment. Okay, so this stress detection is basically identified with the some sort of variable device where they are actually measuring the heart rate variability, blood pressure, and electrodermal activity. Electrodermal activity is nothing but the measuring a property of the skin through some sort of electrical signal. Okay, so that is basically being developed with the one kind of device which is this is Impetica E4. That is a variable band that is being developed. Okay, and through that band means the stress activity is being developed. So this is basically developed in India only, and basically the sample is being collected from the DTU Delhi Technical University. Okay, but because of the lack of time, I'm not covering it in details. Okay, diabetes is having a very close relation with any pandemic, and recent pandemic is COVID-19. Now, during the diabetic slide, we talk about that India is the second. The first one is the China. Okay, and China has impacted heavily during the COVID. Why? Because the diabetic patients are higher over there. If you just observe that top 5 COVID impacted country. Okay, what are those? China, India, America, UK, okay, and Italy. And these 5 is the highest ranked diabetic country. Okay, so diabetic is having a very close relation with the COVID pandemic. Okay, so that's what it is being explained that even diabetic patients are observed to be a more vulnerable in a previous virus attack like SARS, which occurred in 2003, and MERS in 2012, and as well as H1A1, H1N1 in 2009. So diabetic, which we consider as a higher blood glucose, is definitely you can consider a more vulnerable case for any virus attack. Okay, so diabetes is having the highest during the COVID. You just observe that 10% of the cases of the COVID is having a diabetic. Okay, so I am just keeping this impact. Okay, this solution possibly I will pay attention for a few minutes. So this easy band is a variable band which we have developed in a group during a COVID-19 period. Okay, and what is that? That is the variable band. Okay, so during the COVID, contact tracing was a big headache. Okay, what we used to do, we used to identify the COVID patient, and then we identify who are the close contact of that COVID patient, and that we actually being identified manually. Okay, we used to ask the people who is being infected by COVID, and then we quarantine all those people who are been a close contact of the COVID-19. Okay, sometimes we miss few people also because it would be very difficult for me to remember all the people to whom I was in contact yesterday. Okay, it could be for a few seconds. Then also means it is good enough to be go for a COVID infected. So for that, the contact tracing was a big headache. Now for that, what we have developed that we have developed a one solution which is an easy band. It is a variable band. Okay. Now that variable band is having a 3 indicators: green, yellow, and green. Now that indicator suggests that whether a person is a COVID infected or not. If it is a red color, then it is COVID infected. Now see, COVID people is not a means of people where means they cannot roam around. The only thing is they cannot be in a close contact with the healthy person. So if there is a person which is having a red indication, and if there is a healthy patient which is having a green indication, if a COVID infected patient which having a red indication in an easy band, if it comes in a close contact of a healthy patient which is having a green indication in their easy band, then it is automatically converted into the yellow. So we have considered that it is 1.8 meter distance, within 1.8 meter distance, that is a 6 feet distance. If a person which we consider as a healthy comes in a close contact which we consider as a 6 feet distance, then my green indication is automatically converted into the red indication or yellow. Initially it will convert into the yellow, and when a person is a yellow indication, that means it is in a close contact or near a close contact of the COVID, and he or she has to go for a COVID test and prove that he is not COVID infected. And once it is being COVID infected, then through that you need to convert that indication into the red. So through which you can actually identify the COVID population very easily surrounding. Okay. Now we have a application Arogya Setu at that time, which is doing the same thing. Okay. But Arogya Setu has some problem. Okay. That you should have a smartphone first, and you should have a internet on always, so that you can be identified through that particular application. So that is having some sort of problem. So for with that, a contact tracing was very difficult. But through our easy band, that variable solution, which could be adapted easily to identify the contact tracing. Okay. So challenges we already discussed at once, so I'm not going, but data privacy, battery life, accuracy is definitely a challenge. Cost is still a challenge, because I would like to have an accurate solution with the least cost. But that depends upon the advancement of the sensor technology. Currently, I could say that technology is not matured enough so that we can take some sort of critical decision. But definitely, the primary healthcare purpose, you can use such kind of smart variable device. So future trend will be AI-driven predictive health. You could have some sort of AR/VR headset. You could have some sort of implantable and invisible variable device, which you can have. The market trends, you just observed it, that there are many big giant companies like Apple, Samsung, Fitbit, they are investing lots of money in the smartware or smart variable devices. And I can predict that after 2 years, we all will be habitual with such kind of smart variable devices. We will wear, in fact, and we will monitor our important parameter through such kind of smart variable device. So finally, with advancement in the technology, smart variable devices are developing quickly and appear to have a bright future. Smart variables are reshaping the healthcare in our lifestyle, where through our daily routine only, we can able to capture the important parameter. Variable technology can empower the individual by assisting with the early diagnosis, some sort of behavior change in their parameter, and with a self-monitoring capability. So definitely in future, we can observe that some sort of more intelligent smart variable devices will be there, which actually help us to measure the parameter in a seamless manner, where I can go anywhere, I can do any activity. At that time, I can able to capture the important parameter, and it could help us to get the personalized treatment, which is very important. Okay, because each and individual genomic structure is different. So your medicine, generic medicine may not work always. Okay, so for that, the smart variable technology will play a crucial role over here. So with this, I am ending up of my session. Okay, and I would be more than happy to answer queries which is being raised by you. Sadhana, if you can help me out to, because currently I think my screen is being locked. But if any question is there, then I would be more than happy to answer. Yes, any question? I see that there is no. पहले देखो कि कितने लोग joined हैं.
30 participants.
30 participants are there. Because previous one also, there was no question, so I'm not sure whether they are. Yes, any question? Chat box open कर लो. लिख लो अगर है तो. No question. Okay. So thank you all of you for joining for this particular session. Now we will start our next session after 5 minutes. Sir, is there any clinical validation required during the research? Yes, there are some benchmark is there. Clinical validation, if you want to do it, when I say clinical validation, then ultimately I want to test my basically concept or hypothesis on a real subject. Okay, so for that, first of all, you require an ethical clearance. Okay, so ethical clearance where you require to tell that how you would like to collect the data from your real subject. So that there is an ethical committee is there in every hospital, which will evaluate your proposal, where you need to define exact protocol that you will follow in order to capture the data. And then you can go for a clinical validation. So personally, I feel that clinical validation is pretty much required to validate your concept because your model will work very good in a data set. That I have observed because for all my applications, I have converted them into a real product. So I have observed that initially the ML model is giving a very good prediction for my data set. But when I test it on a real subject, however, there is a suffering in the accuracy. So then we have to improve it. So definitely the clinical validation is, according to me, is required in your healthcare related research. Okay. How to improve or increase the security in a device. Okay. So for that various methods are there. Definitely when we talk about a variable technology where we have a IoT empowered device. So your normal security algorithm will not work. Okay. Because your encryption, we have an encryption AES 128.256. Those algorithms are very good for your security protocol, but they may not work for such kind of variable device. Because variable device is always operated through battery. Okay. Now there is no room in a variable device to have some sort of complex algorithm which consumes substantial area as well as power. So for that, the lightweight security algorithm. Okay. So Pooja, maybe you can search out the lightweight security algorithm. One of security algorithm we have also developed the PUF, that hardware security protocol. But because of the time limit, I haven't covered in this particular workshop. Okay, but we did work in some sort of initial security primitive of the variable device. Okay, where the hardware security of the device for our glucometer, iGlu, we have worked on. Okay, but possibly because of the lack of time and available slot, I'm not going to cover, but maybe at some another time, at some another workshop, maybe I would like to cover. Definitely, we are thinking about the second part of this particular workshop, where we will talk about some sort of advanced technology of the healthcare domain, because here we have started with some basic application we are talking about. Okay, but for the second phase of this particular workshop, we are basically focusing on all these aspects. Okay, that security, privacy, and means some sort of you can consider the power module which actually help us to develop such kind of smart healthcare solution. Okay, so there are security protocols are there, lightweighted security protocol that you can adopt it in your smart variable technology. Okay, any other question? If no further question, then We stop it over here. I am not sure Deepak sir has joined or not. Just check it out at the panel. Okay. So Deepak sir will join also in 5 minutes. So we will start in 6:05. Okay. So you can take a 5-minute break. Okay. And assemble over here at 6:05 again. Thank you. Stop video and audio. Audio will mute.